Hello, students. All right. So far we've discussed two conic sections. They were the parabola and the ellipses, right? Well, now we're going to discuss the final hyperbolas. Now, hyperbolas, as you know, it's when the cones, right, are vertically cut and it creates two parts. And that's why they will look like this. And we will show you what this is all about. Okay? Now, 10.3, what are hyperbolas? A hyperbola is a set of all points xy in the plane where the difference of the distance from two distinct fixed points, you guessed it, they're called the foci, is a positive constant. So when you're looking at this, here's what the hyperbola looks like. Imagine the cones sitting on top of one another, and they're cut vertically, right? And you get these two parts. I've shown you that with the figures, right? Now, so you're right. We start with the foci again. So here is your focus. And that's your focus 1, F1, yeah? This is your focus, these are your foci, and it's focus 2. Now, there's a center here, like always, right? It's between the focus. We're going to discuss all the parts in a sec. And what we're trying to tell you is this. From this focus 1, like we'll call this F1, we'll call this F2. From here to here, that distance is we'll call it distance 1. And this right here, we'll just say this is the fixed point xy. This distance here, the second focus to the same xy that we're talking about, anywhere along the hyperbola, we're going to call that a branch. We'll learn that later. And this distance is D1. But we know, this is D2, let's say, okay? Let's call this guy D1, D2, okay? Now we're going to say anywhere we choose, okay? Any point, if we go from here to here, from here to here, when we take the difference of the two distances, they are actually going to stay constant. Equals a positive constant. Constant, and we'll put positive here. Okay? And that's what the definition of a hyperbola is. Okay, so now let's actually go ahead and dissect a hyperbola. So this is a horizontal. This one is a horizontal. Let's write that at the bottom. Are you following along in your notes? This is a horizontal axis, horizontal transverse. We're going to talk about that later. Horizontal hyperbola, okay? We're going to call this a horizontal hyperbola. And you can see that because the branches, yes, these are called branches, so let's write branch here. The branches are going left to right. So we're going to call this guy's a branch 2. There's a left branch and a right branch, right? Okay. Let's try to guess all the parts. And I'm sure that you guessed that this guy is the center. Let's start there. Now, the line that connects, or the axis that connects the horizontal branches, right, is called the transverse axis. Let's write that here. This is a new word, right? Transverse axis. It connects, you can write this as a side note, it connects the vertex, right? This is not much different than an ellipse, right? Because ellipse, we also had center, we also had vertices, and we also had this guy as a vertex, right? This guy is a vertex. And what do you think the point inside of the branch, but farther away from the center, is called? You're right. It's the focus, right? That's the focus. And we could always call that guy like F1, F2, if our convenience, okay? Now, so again, transverse axis is the one that contains the vertex and the foci, okay, in a horizontal hyperbola. And the distance from the center to the vertex, you got it. It stays the same thing as an ellipse, right? It's A. And the distance from the center to the focus is going to be C. Or, in some cases, they call it an F, which seems appropriate to me. Okay? Now, why don't you do this? Now, the next part that you're looking at is the vertical. So why don't you try filling in the rest of the vertical on your own? But I'll write here vertical hyperbola, vertical transverse axis hyperbola, however technical you want to get. Vertical hyperbola. Okay? So go ahead and fill in the branches here. Okay. Welcome back. Did you put this as a center? you notice the transverse axis is going vertically, and that's why it's called a vertical hyperbola. So this guy is the transverse axis, okay? Okay. Now, what is this? What do you guys put for this guy? Let's go in order, yeah? So let's do the top to bottom, okay? Branch. If you got it correct, give yourself a high five, okay? This is the vertex. Well, obviously, this is the focus because this is inside, yeah? So F1. This guy is F2, focus, okay? Did you put branch here? What did you guys put for this guy? Hopefully vertex. And the distance from the center to the focus is always your C. And distance from the vertex to, oh, there's no vertex box, huh? Oh, we did put it. From the center to the vertex is always going to be little a here. So I know what you're wondering. You're like, where's B? If you got the A and the C, where's the B? B is coming up soon, okay? Now, I'm going to give you a few notes to write down, okay? Note. A, B, C are slightly different than that of the ellipse. Okay? You'll see why later, okay? Now, foci is C away from the center. Okay, we know that, okay? And we got the vertex, okay? Now, I'm going to give you this one thing. Now, these are the proofs that I want you guys to kind of challenge yourself with. C squared equals, in this case, A squared plus B squared. So it's kind of like the Pythagorean theorem in a way, right? So ellipsis was C squared equals A squared minus B squared. And that's an easier proof. This one's a little bit more difficult. Try that for yourself, okay? Now, let's see what else you can say. Oh, okay, another thing I can mention is this. You see how this is a transverse axis? Well, you know the other axis that goes this way? That's actually called the conjugate axis. Conjugate. But we'll do that in a sec. All right, so go to the second page of your notes. So follow along, please. Now, you're on the second page, which is part 1's STD form of a hyperbola. All right, now we're going to dissect the standard form. So here is when you have the standard form of an equation of a hyperbola with the center of HK is here. Okay, so it looks familiar. So again, we can start from like a circle. But what do you notice about hyperbola? You're right, the minus is different, but A squared and B squared remain the same. And this is for the horizontal, okay? This is when the transverse axis is horizontal, okay? All right, now let's write some couple of notes. Now, I want you to understand something. These lines here, these are called asymptotes. You see these branches? They're approaching that line, right? They're approaching that line. So that's why they're called the asymptotes. So these are called asymptotes. And you're right, they're linear, and there's two of them. And they go slightly around, right? The branches approach them. And you're always going to do this method when you're sketching a hyperbola, and it's called the box method, I like to call, okay? So it's going to go something like this. You see this guy right here? Isn't that 2A? That's the major axis if you equate it to an ellipse, right? And if you kind of go like this, you see this right here? You create this rectangle. Oh, so slightly tangent to the actual branch. This guy right here, right? You notice that this line is going to go through the asymptote's corners, the rectangle. The corners of the asymptote touch the rectangle, along with this one too. So there's a positive linear and a negative linear. So you're going to always have two asymptotes. Okay? Now, you notice that we talked about this already. This guy was called what? You're right, A. This guy was called what? C, right? Then, this is the transverse axis. This guy is called the conjugate axis. Let's write that. This is the conjugate. Look at these terms aren't as important as the definitions of the actual conic sections. Conjugate axis. And what lies on the conjugate axis is your B. Is your B, okay? All right. So here's your A. Here's your C from the focus to the center. And here's your B, okay? Now, this one, again, let's sum it up. horizontal. This one is your horizontal orientation. Okay? All right. It has a horizontal transverse axis. And notice something here. The x term, x squared term is positive. I'm sure this is how you're going to remember which direction it goes. Okay? Now, of course, the foci always lie inside of the branch. That's why you do the x coordinate of the center plus the amount of c. Okay? Now, let's try to think about the asymptote equations. It's very obvious, don't you think? It's y equals, and it says linear, so you know it's y equals mx plus b. Okay? So that means, let's see. What did you start with? Didn't you start the y-intercept here, which is actually the k, right? So you know you're always going to start from k. And if your k is 0, it's okay. Just put nothing or put 0 at first, okay? Now, I hate saying this, but slope is rise over run, right? So that means from here, I went up b. What did you do? You went to the right or left a. That's why it's plus or negative. And what about the x times x? Well, didn't the x start at x, but it went to the right or left h. So here is the equation for your asymptote. Again, I never memorized this, even though you can, okay? You don't need to memorize this because you can figure it out once you draw the rectangle and once you see your sketch, okay? Now, let's see what else I can say. Again, a squared and b squared, okay? You'll see in your vertical orientation that the a squared and b squared stay the same position always. But what did change? The x minus h squared, they swap places. That's for the vertical, okay? Vertical orientation, okay? Now, for the vertical orientation, let's write a couple of things. Y squared term is positive, okay? Now, why don't you go ahead and try to write for me the asymptote for a vertical equation, okay? So I'll start you off, y equals. And remember, not the transverse axis, it's called the conjugate axis. And you could actually just draw a rectangle every time. I'm going to show you how to sketch hyperbolas too. So this is your A, this is your C, this is your B. So take a guess. All right. Did you get something like, okay, I started K, I'm going to definitely go up A, but I'm going to go left or right B. That's why it's rise over run A over B and x minus h. That's the equation for the asymptote for a vertical orientation hyperbola. Now, if your if your center always starts at 0, 0, the origin, then you know it's going to be x squared over a squared, y squared over b squared, or y squared over a squared, x squared over b squared. So just get rid of the x, h, and the k, just like all the other conic sections.